Okay. Good morning, all. Uh, Now I am sharing my screen. So once again, to get a recap or to get what we have discussed last week, I think 4 days have gone. So small tests are like exercise. So same as go to www.menti.com. I will share my screen. I think it is visible. Is it visible? I think I am sharing my screen. Yes. Okay. Now I am presenting my question. Uh, you can go to www.minty.com and use the code 500613. I think someone is waiting for getting admission. A few minutes. Okay. Go to www.minty.com and use the code 500613. It's large potential bandwidth. Please don't exactly what we have discussed. Whatever you are thinking, please post. That is not a big issue. And please don't share your answers with our group, personal group, or whatever it may be. Low power loss, good. Large potential bandwidth. I think signal security, fast data rate. Okay, signal security. 5 people have responded. I think most of the students are going back to get in a Google what is advantage of communication system. I think so. Low cost, few more answers I'm expecting. Low power loss, flexibility, yes. High bandwidth, okay, okay, good. Optical fiber offers low flexibility, low cost. Some other answers. If it is already is there, no issue. Please type your answer. If already is displayed, if you are thinking some of the answers is there, don't think. Please post and type. Yes, type and post. Higher signal, no jamming at all. What? No jamming at all. So that is in terms of delay you are speaking. I think so. Someone have said no jamming at all. Okay. Okay. Done. No jamming at all. Cheap. Okay. Good. 26 have responded. Optical fibers offers low. What is optical fiber offers low? It I think it is not ended properly. Larger bandwidth, higher signal reliability. Okay, someone said reliability. Okay, 28 have responded. Some other answer I expecting. Any other answer? Or we will stop. Higher bandwidth, faster communication. Okay, okay, we will stop here once again. Okay, we will stop here. I think 51 I responded. 30 people have responded. Okay, I'm stop sharing here. We will go to our presentation. Wait a few minutes. How many people have went to that class Google Classroom and then downloaded that Sway? I think there is advantages of optical communication. How many people have seen? How many students? Please respond either in a chat box or unmute yourself and please say. How many people have went to Google Classroom and downloaded the advantages of optical fiber communication, which I have posted, I think Friday, I think so. I think you following my instructions? Are you there? Not yet means what? Okay, you didn't see. Okay, okay. So go to Google Classroom. Those who are joined already. So visit. I have shared the textbook also, two textbooks, and also the important questions and answers for the first unit, and also the advantages of optical fiber communication. That is important. So if you are not visited, go back and check what are the things is available. Now I am presenting my screen, PowerPoint presentation. Is it visible? Someone please unmute. Is it visible?
Yes.
Okay, I think we have stopped here. Last class we have stopped advantages of optical fiber communication. The same question which I have asked in today session started. So same thing: large potential bandwidth, small size, and lightweight electrical isolation. I think now known is not mentioned this one. That is electrical isolation, not mentioned there. And immunity to interference, then crosstalk and signal security. And most of the people have mentioned signal security, low transmission loss also, and ruggedness and flexibility. Someone said the flexibility also. Then reliability and easy maintenance and potential low cost. So these are the main advantages of optical fiber communication system. So we move to the next one. Suppose if we are not having any optical system in this scenario, what will happen? That is the next one. So the telecommunication field will be failed, and computer networks field will be failed. Television field will be also communication transmission systems will get failed, and medical field will be failed. And these are the things which happened when you are not having any optical system. So what is the solution? So definitely we have to go for optical fiber connection in the entire world. So well, connecting with optical fiber communication is the only solution to avoid whatever the disadvantage we have seen earlier. So it is in our hand. As an engineer, we have to connect the entire world and with the help of optical fiber communication. So if you are having a technique of optical fiber communication establishment, definitely you can achieve the best communication system in the world. So slightly we will move to the next topic, that is nature of light. So definitely we know that when I am having any data, definitely the data will be transmitted in the form of light. So we have to know something basics of light characteristics and everything. So this is the idea. The concept, definitely the light can be explained as in the three way, either rays or waves or photons. So this is general introduction. I'm not going into detail. Already maybe you have studied into the basics physics, and also in the first semester, second semester, we have studied the basics physics and physics 1, physics 2. Definitely you have been undergone this type of all those information. So I'm refreshing those concepts. So nature of light. So rays using optical geometry, the waves in the terms of waves using electromagnetic theory, and photons using the photoelectric effect, that is in terms of light signal. So these are the different idea of light, either in types of ray or waves or photons. So we have to know about optical geometry. If you are knowing the optical geometry, you can explain the light propagation characteristics, how the light signal traveling into the fiber material, and either inside the core material or above the away from the core material. Those things you can identify with the help of optical geometry. If you're knowing the basic geometry characteristics of optical system or light characteristics, definitely you can explain or you can understand the light propagation characteristics inside the core material. That is one thing. Suppose if you are knowing the parameter of electromagnetic theory, you can understand the spectral characteristics. That is how what is the spectrum available, how much spectrum we have utilized, what is unused spectrum, everything you can understand by the help of electromagnetic theory concept. Then photoelectric effect, to with the help of if you are knowing the photoelectric effect, you can understand the lasers and also the photodetectors. Lasers, we know the basic idea of lasers, that is stimulated emission by the help of normally energy transition from E1 to E2. So that is one of the source material for optical communication. Then photodetectors, definitely with the help of photodetectors only we can retrieve original message signal in between the transmitter and the receiver section. So if you know the basic characteristics of optical geometry, you can explain the light propagation, you can understand the light propagation. If you are knowing the electromagnetic theory, you can understand that spectrum characteristics. Then if you are knowing the photoelectric effect, you can understand how the lasers and the photodetectors are working together. So those you can understand from this three different phenomena. And this is the general idea. Whatever we are discussing now, where we are. We have a visible light transmission system and also the ultraviolet, and that is IR region. Either in a visible light or in IR region, that is important. Visible light, suppose if you can see the light from any of the laser source or LED source, that is a visible range. Suppose in a traffic signal, you can see red light and orange and the green. So those are the LED characteristics. That is also a optical source. So different ranges available between 400 nanometer to 780, approximately 780 nanometer. But simple concept, when you are seeing, or when you can as a human being, if you can see any optical source by using your eyesight, that is a visible range. So definitely the LED range in a traffic signal or wherever, if you are seeing, maybe in a laboratory you can use LED characteristics, and also maybe you can see in a maybe microprocessor or in a microcontroller, you can see in a laboratory kit, there you can see some of LEDs is blinking. So those LEDs which comes under the visible light area, that is between 400 nanometer to 780 nanometer. So if goes beyond, that is above 780 nanometer, we know that is invisible range, which already we have discussed. One is 850 nanometer, second one is 1300 nanometer, and third is 5050 nanometer. So we have a three window system. One is first window, second window, third window. It is invisible range and IR region. So definitely it is above 780, approximately from 800 nanometer to 1550 nanometer is invisible range. So your lasers are also, some of the LED also is available in an invisible range. But purely in a real scenario, in a real time, if you are going with the help of optical system, definitely they have to go by with the help of what to say, that is lasers. So lasers, where you are picking for which application you are choosing for, laser 850 or 1330 or 1550. So we have a clear concept. One is visible range, another one is invisible. If it is a visible, it may be a LED. So definitely the range will be 400 nanometer to 780 nanometer. So definitely in between 670 to 780 nanometer will be the range of your visible area. So this is the area that you can use your LED characteristics. Suppose if it is going beyond 780 nanometer or above 780 nanometer, definitely we have a three window system: 850, 1330, 1550. It is invisible range. So this is normal spectrum analysis. So from this particular image, you can understand that where we are working in an optical system, where we are working either in a visible range or in an invisible range, either below 780 nanometer or above 780 nanometer. So in terms of micrometer also, you can say If it is 780 nanometer or 800 nanometer, it is approximately 0.8 micrometer. So same as 1300 nanometer means it is 1.3 micrometer. So we have a basic conversion between the nanometer and the micrometer characteristics. So this is idea of as an engineer, as optical communication system, we have to know where we are working. We are not working above 1.6 or a micrometer or below 400 nanometer. So as an engineer, we have to know where we are working, either in a visible or invisible range. So based on your transmission system or based on our communication system, we have to pick which source material or which nanometer I am going to use for my application. That is the thing you can understand from this diagram. Next one is, as a light characteristic, we have a definitely we can understand two different type of light system. One is incandescence, another one is luminescence. So the light is a transverse of electromagnetic wave that can be seen by humans. The wave nature of light is illustrated through the experiment of diffraction and also the interference. So either incandescence light characteristics, and another one is the luminescence. We have two options. One is incandescence, another one is luminescence. Incandescence, if the temperature is greater than the 800 Kelvin, that is important, 800 K. So if any of the object or any of a material or any system that emits the greater than 800 Kelvin temperature, definitely that is incandescence light. So incandescence is the emission of light from the hot matter, definitely is approximately greater than the 800 Kelvin. So luminescence is the emission of light when excited electrons fall to the lower energy level. Already we know the basic characteristics, how the light is generated. We have a E1 level, E2 level. From E1 to E2, automatically the electrons will move from E1 to E2. So whenever some of the electrons or some of the energy particles automatically will fall from E2 to E1, that is from the higher level to lower level, that time you will get, definitely you will get some amount of energy in terms of photons. The photons is nothing but your light characteristics. So some of electrons will not fall from E2 to E1. So that time we have to stimulate those electrons from move from E2 to E1. That is your stimulated emission. That is the basic characteristics of your laser system. So luminescence, generally luminescence is the emission of light when the excited electrons fall to lower energy level, that is from the higher energy system, that is E2 to E1. That is the general characteristics, general idea behind the incandescence and the luminescence. The speed of light, definitely we know with approximately 3 into 10 power 8 meter per second. So, but exactly 299792458 meter per second is our light speed and the normal. We know that is the basic characteristics. We have basic idea. Another one is the light characteristics. The amplitude of a light is related to the intensity. The intensity is absolute measurement of light waves. So with the help of amplitude, that is intensity of a light energy, you can understand how much energy we have transmitted from one point to another point. The frequency of light wave is related to its color. Definitely, we know. I already told that it is invisible. If it is invisible range, definitely 400 nanometer to 780 nanometer, or approximately 800 nanometer. So already I told that example is in a traffic signal, you have three different colors. One is red, orange, and green. So based on that, you can choose the color, which depends on the frequency. Frequency is exactly related to the color characteristics of your choosing LED. So that is another one more idea of light characteristic system. Either it is a monochromatic or polychromatic. Those things are already have maybe you know very well. The monochromatic light is described by only one frequency, that is the laser is a monochromatic signal. So from the laser source, you can get only 1 nanometer. Suppose if I am choosing third window, the third window deals a parameter in the nanometer of 1550 nanometer, that is 1550 nanometer. So if you are choosing any laser source in the particular third window, you can get only one frequency, that is only 1 nanometer from the particular source. That is why the laser is the high intensity characteristics, and also you can transmit for the long distance communication, since it is a monochromatic signal. The polychromatic signal light is described by different frequency. Definitely we know the white light is a polychromatic signal. Generally we have one more question. White light of polychromatic signal. What is white Gaussian noise from in our communication system generally? White Gaussian noise. What is white Gaussian noise? If you know the answer, please post in the chat box or unmute yourself. Then please answer for the particular question. What is white Gaussian noise? Collection of all kind of noise. Okay, good, super. White Gaussian noise. Or maybe you have heard the word AWGN, additive white Gaussian noise, or white Gaussian noise distribution, a Gaussian distribution, that is bell-shaped analysis. Any other answer? Collection of all kind of noise. Please unmute yourself, then answer for the particular question. Equal intensity at a different frequency. Okay. Some other uniform power noise which has uniform power. Okay. So generally, white noise. Maybe I have a in terms of I can shoot the question in another way. White color consists of how many colors? How many colors in white color? Maybe in another. Definitely all the colors, all colors. So from that question itself, we can understand that if you are hearing the word white color or white Gaussian guys or white AWGN, additive white Gaussian noise, definitely whenever we are dealing the parameter additive white Gaussian noise or white Gaussian noise, you are analyzing all the frequency ranges, somewhere from starting point to somewhere in our higher range frequency to lower frequency, or from the lower frequency to higher frequency. If all the frequency ranges, if you are analyzing, that is with white Gaussian noise distribution. Maybe you can see the one bell-shaped curve system. Midpoint you have a reference value, below that is maximum value is 1. So either left hand side 0.5 minus 0.5, or another one is another point that is half of the system, that is totally have a 1. That is in terms of a white Gaussian noise. So wherever if you are dealing white colors, it consists of it consists all the colors. So same case in our frequency also, the white color will consist of all the frequency ranges. So that's why in any communication system, maybe you can hear the word white Gaussian noise distribution analysis. So if you are going in the particular way, it means that you are analyzing the entire frequency spectrum or all the available frequencies. That is the idea behind doing character analysis of white Gaussian noise. So that is important. Same, we have a in white color we have all types of that is polychromatic signal. So the light sometimes also known as visible light and the contrast from UV and IR. So we have discussed in visible light. So it is a 400 nanometer to 780 or approximately 800 nanometer. So spectrum, bandwidth, and wavelength, definitely you know the graph between relative intensity and frequency is called the spectrum. And bandwidth, definitely from the difference between the higher frequency and the lower frequency. The wavelength lambda equal to C by F. You know, basic idea of this one. And this is polarization. Whenever we are dealing any electromagnetic signal, without a polarization, we cannot analyze how the signal is transmitted from one point to another point. So the orientation of electric and magnetic field is called polarization. So we have a major 3 classification. One is the linear polarization, another one is elliptical polarization, another one is circular polarization. So you can see here, when it is a linear polarization, we have a XY Z axis. You can see the difference between the either linear or the circular right-hander polarization. The elliptical is right-hander. In a circular, we have a right-hander and left-hander. Also in the elliptical, we have a right-hander and left-hander polarization. So generally, the major idea behind the concept is when it is a linear XYZ, You can see the three different diagram, GIF diagram, GIF animated system. You can understand from this easily how the signal is transmitted when it is a linear polarization, or how the signal is transmitted when it is a circular polarization. You can see in a circular polarization, the entire area with respect to the z-axis. Z-axis is normally the transmission direction, and xy, we know the basic in any graphical system we have a xy system. Then z is the propagation direction. Generally, the z direction will be the propagation direction. So this is about the circular, and this is the elliptical system. We know the elliptical characteristics, basic characteristics, eccentricity, and all those characteristics comes under the elliptical parameter. So these are three different analysis. One is linear polarization, either the signal will with respect to xyz, xy6, and also the circular xyz, and elliptical also xyz. So generally we have a major classification, either linear or elliptical or circular polarization. From this diagram you can understand that how the signal is transmitted generally in a when you are doing any polarization technique in electromagnetic field. We know basically all the electromagnetic signals, or maybe electromagnetic information will be converted into the form of light with the help of either laser or LED. So once you are converting those electromagnetic signal into the form of light, definitely the signals will carry those information either in linear or elliptical or a circular polarization. So this is the idea behind this particular polarization concept. And one more thing, why we have to go for the polarization? That is important. Could you please share what is the reason behind, or why we have to go for polarization? What is the concept behind, or what is the need of polarization? Why we have to go for polarization? That is one main thing. What is why we have to go for polarization? Or without polarization, if I am transmitting, what will happen? With the help of polarization, what advantage I can get from the transmission? Any idea? If you have any answer, please unmute yourself. Then please post your answer. Why we have to go for analyzing the behavior of electric field with respect to magnetic field and vice versa? Okay, that is the answer, the orientation of E and H field. So okay, definitely sure. So in which way that is in a x-axis or in a y-axis or in a z-axis, based on that, how the electric and magnetic field is fall into the particular direction. So that is the one thing for analyzing and behavior. And one more thing, generally by the help of polarization, you can increase the capacity also. Suppose I have maybe five set of information, or five electromagnetic systems, or five information. Let's say for A, B, C, D, E, whatever maybe. A signal, if I'm transmitting the same medium with the help of a circular, or maybe the B signal transmitting with the help of elliptical, or C signal with the help of linear. So when I'm changing the polarization characteristics between the or among the available information, I can transmit all those information in a particular medium, or in a, since it is an optical fiber, you can transmit all those information in a based on the polarization characteristics. That is one thing. You can increase the capacity based on the polarization also. If you want to increase the capacity, you have to understand the basic idea of polarization. Then only you can increase the capacity. If you are not knowing the basic characteristics behind the elliptical and also the circular polarization, definitely you cannot achieve the capacity increase in our system. It may be a wired or wireless. So that is the one thing. But the general idea, the orientation of E and H with respect to X, Y, Z axis characteristics. That is one thing. Thank you, Divishti, for that answer. So this is idea of linear polarization, elliptical, and circular polarization. So energy in terms of photon, E into Hp, H is Planck's constant, 6.625 into 10 power minus 34 system. That is the idea energy level. And V is frequency, that is an energy which we are having. Both the value you can understand what is the energy of your system. So the photon, light energy is always emitted to discrete units called the photon or quantum. That is a photon. Already told that from E1 to E2, the electron will automatically move from E1 to E2. So from the E2, some of the electrons automatically fall into from E2 to E1 or higher energy to lower energy. Some of the electrons will not fall. So that time we can have to stimulate. I have to apply the external force to move from E2 to E1. So that energy will convert as a photon. That is your light signal. So we will discuss maybe detail in our laser principles in third unit. And once again, till now we have any question, please answer. If you have any question. Are you following my idea? Someone please unmute. Unmute yourself and speak. Till now, you have any doubts? Basic characteristics of light and everything. If you're not having any idea, we will go next topic. Important 2 mark, refractive index. Shall we? Someone please respond. Okay. We will move to the next one. I stopped my presentation. Now I am presenting my screen once again. So is it visible now? Is it visible? Okay, thank you. So important 2 mark question, define refractive index. Definitely you can expect in this question in a 2 mark, refractive index. So slightly we move to the next area in detail about the optical characteristics. So till now we have discussed the basic characteristics of light, how the light signal, the classification of light, maybe incandescence and luminescence, what is the energy level, what is the speed of the light, 3 into 10 power 8 meter per second. Then some of the characteristics behind the polarization, everything, basic light characteristics area. So now we are going to deep into the our especially for optical communication system. So before going to that, we have to know some of basic definitions in optical system. So first one is refractive index. So refractive index is the ratio between the light speed in a vacuum and the light speed in a medium. That is the difference. Light speed in a vacuum is totally different. The same light speed when you are transmitting into the medium, definitely that is totally different. So that is the thing we can understand from here. So this is the ratio n. Refractive index denoted as n value, n equal to the light speed in a vacuum is to the light speed in a medium. When you're having the average of these two, or when you're having the value of these two parameters, you can identify the n. So typically the n value will be 1.5 or 1. Based on the material which you are choosing, the RI profile value will differ. The short term of refractive index is RI profile. Refractive index is RI profile. So for the using of RI profile, what you can understand that how much the speed of light is reduced in the medium. That is the important thing. If you are having in a normal vacuum, so that time definitely the light speed will be differ. When you are transmitting the same light into the medium, that is totally differ. So when you are getting these two value, you will get n value. So by the help of n, how much the speed of light is reduced in our medium or in optical fiber system, that you can understand by the refractive index profile, that is RU. So you can see here, this is a normal line. Suppose light falling on from this particular side. This area is a low refractive index, that is a ash color area. Yellow color is a high refractive index. It slows down the light characteristics. And green area is very low refractive index profile. So whenever the refractive index profile changes, automatically the light propagation will getting differ. You can see from this particular point, that is interaction interface point between the yellow and ash color, you can see the light is falling the same direction. Once enter into the high in the refractive index profile, automatically the light will get slightly change the propagation, maybe transmission idea. So you can see the small bend in the light transmission medium. So whenever this is considered as a medium 1, this is a medium 2. Generally, when you are having the refractive index profile changes from low refractive index to higher refractive index, definitely there will be some change in the light propagation. That is the thing you can understand from this particular animated area. You can see in a very low refractive index, definitely there also we have some changes in the light propagation. That is one thing you can understand from this diagram. So I told that it is value between approximately it is 1.5 from 1 based on the material, definitely it will change. So characteristics of light in the vacuum is 3 into 10 power 8 meter per second. If you are knowing the value of relative permittivity, it is purely based on the real characteristics or real term. On a dielectric, if you are using dielectric material, the material is the relative permittivity epsilon I. So that is one thing from the refractive index. So refractive index, that is the 2 mark. The answer for the 2 mark is you can understand that how much the speed of light is reduced in our optical medium. The formula for is n equal to C in a vacuum or C1 or Ci in a medium. So between these two values, you can understand, you can get some value that is constant value or n1 based on the material you have to analyze. So that is the refractive index profile or Ri profile. So n1 or n2. So n1 is medium 1, n2 is medium 2. Based on that, you can understand then from which medium to which medium I am transmitting the information. So this is idea behind the refractive index. You can see here refractive index in any dielectric medium, the speed of light becomes V equal to C by N. The factor N is the index of refraction or refractive index. Maybe some in a university question paper or any semester question paper, they can term a word as index of refraction. That is also a refractive index of the medium. So please don't confuse that. If they are asking define index of refraction, please don't misunderstand that. We didn't study. The index of refraction is same as of your refractive index. So that is idea. So generally we have a n1 characteristics. So based on that, you can find out what is speed of light in the particular medium. So approximately we'll go to the next one. So this is the Ri profile of available materials. If it is the air, the Ri profile is 1. If it is the water, 1.33. If it is a magnesium fluoride, 1.38. We have a different type of materials. If it is a silica, 1.46. If it is lithium, 2.25. If it is indium phosphate, 3.21. Generally, you have the idea. Please note it down. This is important for the calculation. Definitely, you have to use this value. Maybe we'll see the calculation maybe next class. Air is a medium 1 and water is a medium 2. Say for example, if the light, laser light in the lambda 1550, the light traveling from the medium 1 to medium 2, calculate the light characteristics. If they are asking that question, the medium 1 is air. So for example, if they are giving the medium 1 is air, you have to mention the n1 is 1. If the medium is water, the n2 is 1.33. So likewise, if they will give a medium 1 and medium 2 from this particular maybe snapshot or first particular slide, you can understand that what is the refractive index profile of air, what is the refractive index profile of water. From that, you can calculate your original light characteristics of your system. So particularly, generally, any refractive index material varies with a number of parameters such as the wavelength and temperature. So maybe you can see here, the index varies with the number of parameters like wavelength and temperature. If I am changing the wavelength parameter, definitely the n1 profile, that is my refractive index profile, definitely will change, and also based on the temperature. if all the materials, we know basic characteristics, all the materials is purely related to the temperature effect. If there is any change in the temperature, definitely the basic characteristics of any material will get changed. So simultaneously, the RI profile will get changed. Due to that, it leads to the your speed of light will get changed. So we have an interlink between the wavelength and temperature. If there is any change in the temperature, it affects the material. If there is any change in the material, it affects the refractive index profile. If there is any change in the RI profile, definitely it affects the light speed of the light in the particular medium. Clear? So this is idea of refractive index system. Any question behind this refractive index? RI profile, light speed in our medium. So that is the idea. So generally n equal to C in the vacuum, the speed of light in the vacuum to the speed of light in the particular medium. When you are knowing these two value, you can understand what is your n for the particular medium. Either if it is air to water or water to air or air to diamond, or maybe we have a analysis later on from medium 1 to medium 2. What is medium 1 and what is medium 2? If you're knowing what is medium 1 and medium 2, you can understand what is RI profile. So definitely, if you're knowing the RI profile, you can understand that the speed of light in a particular medium. So that is the concept behind the refractive index. Any question in the refractive index? Any doubts or any idea? Okay. So that is the concept behind of refractive index profile. You can understand that definitely basic characteristics you have to know refractive index profile of your fiber system. If you are not knowing the RI profile, definitely you cannot understand what is the behind maybe the advantages or how the signal is transmitting from one point to another point. You cannot understand. We have a maybe plenty of basic characteristics of optical system. What is RI profile, what is Snell's law, everything which we are going to discuss one by one. So basic concept is too important. If you are not knowing the basic concept, you cannot understand how the signal is transmitting from one point to another point, especially in optical fiber system. That is the thing. So we'll go to the next topic or next idea. Once again. This is Snell's law. Maybe you know the basic physics itself, Snell's law. How many people have studied this concept in basic physics? Snell's law. Snell's law. Please unmute. I don't know how many people are following. Anyone? Please unmute. Are you following my concept? Is it okay? Someone please respond. Is it okay? We will discuss. I will stop here. What we have to do. So what is
Okay,
the time? Huh?
Okay, sir.
Karthik. Okay, thank you for your reply.
Okay.
So what is the time for the particular class?
11 o'clock.
11 o'clock.
So 11 o'clock. Okay, thank you. We will stop or we will conclude. Maybe. Okay, we will stop here because when you are entering into Snell's law, we have to discuss more. I think so. So maybe I can once again. If you have any question, please post in that chat box. Definitely I will answer. Or I will stop presenting. Any questions?
Nothing, sir.
Okay. Any other light characteristics? I think we have discussed basic light characteristics and also the parameter how the signal is transmitting, what are the basic light systems, and incandescence and luminescence, and maybe polarization characteristics and RI profile of your optical fiber. everything we can achieve. Uh, I will take attendance once again. Start from 1, 1, 2,
Sir.
1. This is number 1.
Yes.
Okay, 2, 3.
Sir.
Okay, 3,
Sir.
4,
Sir.
5,
Sir.
6. Register number 6.
Six discontinued, sir.
Huh?
Register number 6
Left.
Yes, sir.
Okay, 7, 8,
Sir.
9,
Sir.
10,
Sir.
11,
Sir.
12,
Sir.
13. 13. This is number 13. 13 is absent. 14, 15, 15 absent. 16,
Display.
17, 18, 19, 20.
Sound interested, sir.
Okay, பார்த்துட்டேன். 20, 20, okay, 21,